Hi, this is going to be lesson 4.1. We're going to be representing linear relationships with graphs and tables. So let's get started. Okay, like I said, this will be representing linear non-proportional relationships. And the standard will be I can represent linear relationships using tables and graphs. And this will be from 8F3. Interpret the equation y equals mx plus b as defining a linear function whose graph is a straight line. Give examples of functions that are not linear. So here I'll close myself out here, and this says the slope is m question mark. The y-intercept is b question mark. So that's what we're going to be learning about today. We already maybe talked about that a little bit. Let's take this in more depth. Okay, writing linear equations from tables. So the equation y equals 3x plus 2 gives the total charge y for one person to rent a pair of shoes and bowl X games at Baxter Bowling Lanes based on the prices shown. We're going to show the table in a minute. Make a table of values for this situation. So first I just want to point out that this 3 is the rate per game, $3. This 2 is the cost for shoes. Now, when you go bowling and you rent shoes, you only pay the cost for the shoes once. You don't pay for every game that you play to rent the shoes again and again and again. You just rent them for one price. So that's really basically what that equation is showing. So let's take a look. So X is going to be the number of games bowled. Remember how the price is going to go up based on the number of games you bowl, and Y is going to be the total cost that's going to be. Notice how the 2 is going to be your $2 flat fee for the rental of the shoes. So choose numbers for X that make sense. So you're not going to pick a game of like 2.4 because you're not going to play 2.4 games. You're either going to play 1 game, 2 games, 3 games, 4 games. They're going to be whole numbers. And you're not probably going to pick 100 because I doubt you're going to play 100 games of bowling when you go bowling. So you're going to pick reasonable numbers that make sense with the problem. So let's pick, we're going to plug our chosen numbers in for X. So let's pick some numbers. So let's pick 1. So you bowl 1 game. So we're going to plug that in. We have our equation y equals 3x plus 2. So let's plug our 1 in there. Remember, with the order of operations, you do multiplication before you do addition. So we do the 3 times 1 first. That'll give us 3, and then we have the plus 2. So then we add y equals 5. So let's put 5 into our table up there on top. That's our total cost. If we bowled 1 game, we would pay $3 plus the $2 for the shoes. What if we bowled 2 games? Let's put the 2 in there for the X. Remember, you do multiplication first. So first we do the 3 times the 2. That would give us 6, and then we have the plus 2 yet. So 6 plus 2 is going to be 8. So it would cost us $8 if we bowled 2 games. Notice how the $2 is only a one-time fee versus we're paying $3 for the first game and $3 for the second game. Okay, let's do another number. How about if we bowled 3 games? Let's plug 3 in for X. 3 times 3 is 9, add 2, y is 11. And then finally, let's say we bowled 4 games, and that would make sense. So put 4 in there, 3 times 4 is 12, 12 plus 2 is 14, y is 14. So we made our table of values. Okay, let's do another one. Francisco makes $12 per hour doing part-time work on Saturdays. He spends $4 on transportation to and from work. The equation y equals 12x minus 4 gives his earnings, y, after transportation costs for working x hours. Make a table of values. So what is this really saying? Let's get my little thing here. This is saying he makes $12 an hour. But he has to spend $4 driving to work and back. Okay, so he's losing $4, but he's gaining $12 for every hour that he works. That's what that means. So let's make a table of values. X is going to be the number of hours that he's working. Y is going to be how much he earns. So we're going to choose numbers that make sense. For example, he probably wouldn't choose 100 because most people don't work 100 hours, right? Unless they're crazy. Okay, so plug your chosen numbers into your equation. So we're going to start with 2. Let's say he worked 2 hours. So there's our equation. We're plugging in the 2 for the x. Remember, you do multiplication first. So 12 times 2 is 24 minus 4 for the transportation cost. So 24 minus 4 is 20. So that's going to become our y value. Let's pick another number. Let's say he works 3 hours. We're going to plug the 3 in for x. 12 times 3 is 36 minus the $4 for gas. He's going to make $32. So that's going to go in our y value for our table. Let's pick 4 hours. If he worked 4 hours, it would be 12 times 4, 48, minus the $4 for gas. He would make a total of $44 that he could take home in his pocket, not including any of the tax that the government takes out of your paycheck. Okay, next one, if he worked 5 hours, it would be 12 times 5 or $60 minus 4 for the transportation costs. So his total earnings would be $56. So there's a table for Francisco and his job. Okay, you get to try making a table. See you back in a moment. Okay, welcome back. I just wanted to say that, and just come on here for a second. I just wanted to say that if you guys, if I can get on there. Won't let me on. There I am. Okay. So I just wanted to tell you guys that it's a good idea to go back through. I'm sharing all the slides with you. Go back in the present mode and you can see everything step by step. So from now until about February, doing that would really be beneficial for you. Okay, I'm going to go back off again. Okay, let's keep going. Constant rate of change, but not proportional. What does that mean? A proportional relationship, remember, between two quantities is a ratio where one quantity to the other quantity is constant. That is also called our slope, right? The change in one quantity to the other, the slope is constant. The graph of a proportional relationship is a line through the origin. Remember, the origin is at 0.00. So for example, I'm sure it's going to show something, but let me just draw this. Where is 0, 0 on this graph? Right where they cross, right here. This is 0, 0. So if we had a graph with a line that went through 0, 0 here, I wanted to change colors for that. We had a graph that went through the line 0, 0. That would be a proportional relationship. Relationships can have a constant rate of change, but not be proportional. So they can have the same slope. Now, how would that look? So if I had a graph like this, and my line went like this, notice how it's not going through this point right here, 0, 0. It still has a constant slope. If my line was straight there, I'll try to draw it a little bit straighter here. If my line was straight, I would have a constant slope, but I would not have a proportional relationship. That comes when you have things like a shoe fee for bowling, or you have a transportation cost to drive to work. It's not per hour, it's just the one-time cost. So it's clear. Constant rate of change, but not proportional. The entrance fee for Mountain World theme park is $20. Visitors purchase additional $2 tickets for rides, games, and food. The equation y equals 2x plus 20 gives the total cost, y, to visit the park, including purchasing x tickets. So what this really means is you have a $2 per ticket cost, and then just $20 to walk in the door. You don't pay $20 for every ride, you just pay $20 once to get in, okay? So that's what that equation is saying. So step one is to make a table. So x is going to be our number of tickets that we buy, and y is going to be the total cost that we're spending. So y equals 2x plus 20. We're going to pick numbers that are reasonable. So let's say we don't buy any tickets, we just go walk around, we don't like rides, so we're just gonna walk around. So we're gonna put 0 in for the number of tickets we buy. 2 times 0 is 0, plus the $20 to get in, we're gonna pay $20 for the day. What happens if we buy 2 tickets? Plug that in. 2 times 2 is 4, plus the $20 to get in, our total cost is gonna be $24. What if we buy 4 tickets? Plug that in for X. 2 times 4 is 8. 8 plus 20 is $28. Okay, see where this is going? Let's say we put 6 tickets. We bought 6 tickets. So that would be there. 2 times 6, 12 plus 20 for our admission, $32. And finally, what if we bought 8 tickets? 2 times 8 is 16. And 16 plus 20 is 36. $36. That was our table, okay? The entrance fee, okay, we already talked about this, it's the same problem, but we're going to talk about some more steps. Now we're going to plot the points and make a graph. We're trying to decide if it's proportional or not. So we're going to plot all the points we just had on our table there into a graph. So number of tickets, our X is always on the bottom and our cost Y is on the up and down, the Y values. So I picked numbers that worked with this problem. So they go up by 1s on the bottom, they go up by 4s. Every line goes up by 4 on the top. Sometimes you have to think about what's your best way to label your axes. So let's plot our points. So we have 0, 20. We have 2, 24. We have 4, 28. We have 6, 32. And we have 8, 36. Now what happened to it? Where did it go? We're going to find the rate of change between each point and the next. Okay, so there's our table again. There's our graph, our points. Now let's find the rate of change. Okay, the rate of change or the slope is y2 minus y1 over x2 minus x1. Okay, so 24 minus 20 over 2 minus 0. So what I did is I took the 24, the y value, that's my y2. This is my y1. This has to be my x2 because they're partners. And this has to be my x1 because they're partners. Okay, and I plug those into this formula down here, which now disappeared because of the black thing there. And I figured it out. So 24 minus 20 is 4. 2 minus 0 is 2. 4 divided by 2 is equal to 2. That's my rate of change between those 2 points. So now I'm going to do it again for the other points, right? So now I'm going to do 28, this point here, these 2 points, and then these 2 points. So 28 minus 24, this is now my new y2. This is my new y1. This is my new x2. And this is my new x1. Plug those into the formula. Solve, do the math. You get 4 over 2, which equals 2. Do that for the next set of points. So now we're going to do our y2 is going to be 32. Oops, I wanted the skinny one. y2. This is our y1. This is our x2. And this is our x1. Okay, plug them into the formula. 32 minus 28 over 6 minus 4. That gives us 4 over 2, or 2. Okay, and then our final point is to do the 36. Oop, there it goes. 36 minus 32 over 8 minus 6. And I get 4 over 2, or 2. So notice how it's constant. The rate of change is constant. The slope is the same on the line. Notice that the rate of change, the slope is 2, the same as the price of a ride or a game ticket. The rate of change is constant. The price of the ticket does not change. It's always $2. Okay, but Find the ratio of y divided by x. Notice that y divided by x is not the same as the change in y over the change in x. The change in y over the change in x is y2 minus y1 over x2 minus x1. That is not the same thing as this. This is just y divided by x. Okay, don't get those mixed up. So let's put our table back up there again, and let's do y divided by x. So we're going to do 20 divided by 0, 24 divided by 2, 28 divided by 4, 32 divided by 6, and 36 divided by 8. Let's try that. Here's our graph again. So ratio of y to x. Well, 20 divided by 0 cannot be done, right? That's undefined. You can never divide by 0. 24 divided by 2, that's going to be 12. 28 divided by 4 is going to be 7. 32 divided by 6 is going to be 5.3. And 36 divided by 8 is going to be 4.5. You can use your calculators to make sure that that's correct, but I won't do that on the video here. So the ratio of y to x is not constant. It's not the same. And there is no point 0, 0 on our graph. The relationship between the number of tickets and total cost is not proportional. So this y over x is for determining if it's proportional or not. The change in y over the change in x is the slope. They're different things. Notice how our graph does not go through this point right here, this 0, 0 point. Okay, what else do we want to know about this? Would it make sense to connect the points on this particular graph? Would it make sense to take a line and draw it and connect the points? Yes or no? Well, could you buy 2.4 tickets or 3.7 tickets or 4.5 tickets? No. So the lines, the only thing that works is the points, nothing in between, right? It doesn't make sense to connect it. The number of tickets can only be whole numbers, not partial tickets. So sometimes it doesn't make sense to connect the dots. Okay, you get to try this. I'll see you back in a moment. Okay, welcome back. Let's continue. Okay, linear equation. A linear equation is an equation whose solutions are ordered pairs that form a line when graphed on a coordinate plane. The ordered pair would be like x, y, right? Trying to get in here, x, comma, y. That's y. That's an ordered pair. Okay, a proportional linear equation has the formula y equals mx. A non-proportional linear equation has the formula y equals mx plus b. That b is your entrance fee. That b is your bowling shoes fee. That b is your transportation cost. Okay? It doesn't depend on how many hours you work or how many tickets you buy, right? Or how many games you bowl. Y equals mx plus b. M is your slope. B is called your y-intercept. If somebody intercepts the ball, they get the ball, right? So your y-intercept is where the line crosses the y-axis. And then x is the point, the x point on the graph. And that y is the y point on the graph. That's your x comma y in parentheses. That's your x comma y point. That's a point on your linear graph. Okay, that's what x and y stand for. The y-intercept, let's talk about that a little bit. That's the b. We just call it b, just like slope is called m, okay? So the y-intercept is where the line crosses the y-axis. So where is the y-intercept here? Right there. Your b is at 0, 0. It's crossing this y line right there. A proportional relationship will have a graph that crosses the y-axis at point 0, 0. There it is, proportional relationship. A proportional linear equation has no b because the b is just 0, so they don't put it. Don't say y equals mx plus 0, you just say y equals mx. A non-proportional relationship will have a y-intercept of some number because the graph of the line has shifted up or down from the origin, like your bowling shoe fee or your entrance fee to your park. Notice how this line now is not at 0, 0, it's moved up. It can move up there. The y-intercept is where it crosses the y-axis. Notice how instead of it being at 0 here, it is now at 1, 2, 3, 4, 5. It's at 5 now, isn't it? It's shifted up 5 units. Non-proportional relationship. Okay, you have some entrance fee or some bowling shoe fee. A non-proportional linear equation has a b. Y equals mx plus b. M being the slope, b being the y-intercept. Okay. Is that a proportional relationship or a non-proportional relationship? Exactly. It's going through 0, 0. Your b is equal to 0. It's a proportional relationship. Y equals mx. Proportional or non-proportional relationship? Non-proportional. It does not go through 0, 0. B is equal to 5. Y equals mx plus b. In this case, it would be y equals mx plus 5. It's your y-intercept. Proportional or non-proportional? Exactly. Non-proportional. It does not go through 0, 0. It has a b of -3. Actually, -4. It looks like I was down one, counted wrong. That would be y equals mx minus 4. And the last one, proportional or non? Yes, proportional. It goes through 0, 0. Y equals mx. No b. Okay, which graph shows a y-intercept of -2? -2. Yep, there it is, right here, -2. The line crosses the y-axis at -2. Which graph shows a y-intercept of 3? Yep, right there, it's at 3. The line has shifted up 3 from the origin. Which graph represents y equals -2x minus 4? The -4 is your y-intercept. Exactly, that is where the y-intercept is at, -4. That line is shifted down 4 from the origin. And finally, which graph represents y equals -2x? There is no b. That means the y-intercept is 0. Exactly. What is the y-intercept of this graph? -5, right? It's crossing it right here at -5. It has a slope of 0. It has no slope. There's no hill there. What is the slope of this graph? I just told you it's 0, right? What is the equation of this line? It hasn't got any slope. Y equals -5. There's no mx because there's a 0 there, right? There's no slope. So y equals -5 is the equation of that line. No, there is no slope, so the equation doesn't have an x. Okay. What is the y-intercept of this equation? Y equals -4x. The y-intercept is 0, and the line goes through the point 0, 0, the origin. If there's no b, the intercept, the y-intercept is 0. There it is. Y-intercept equals 0. Is this a proportional relationship or a non-proportional relationship? It's going through 0, 0, right? So it's a proportional because the line goes through the origin. What is the equation of this graph? Y equals X. That's actually, that graph's supposed to be right on the 0, 0. So that has a slope of 1 and it goes through 0, 0, so there's no B. It's Y equals X. That's a famous line linear equation that you're going to use a lot in the future. Okay, interpreting linear graphs. How far has this graph shifted from the origin in this equation? Y equals X minus 2. How far has it shifted from 0, 0? Did you say -2? Because -2 is the y-intercept, then you are correct. The graph has shifted 2 units down from the origin. Okay, it went from 0 to -2. It's called a translation. The translation is a shift of a graph, up or down, left or right. Okay, you get to try this. See you back in a moment. Okay, welcome back. Graphing linear equations. Okay, I want to go back here for a second. Sorry about that. Okay. So the diameter of a Douglas fir tree is currently 10 inches when measured at chest height. Over the next 50 years, the diameter is expected to increase by an average growth rate of 2/5 inch per year. Equation y equals 2/5 x plus 10 gives y the diameter of the tree in inches after x years. Draw a graph of the equation. Describe the relationship when graphed on a coordinate plane. So 2/5 here is your growth rate. 10 is where it started out. This is where it is. It's 10 inches to start with. Okay. Step 1, make a table. So we know how to do that pretty well now. We just plug in our numbers into our equation. So we'll start with 0. Plug 0 in for x. 2/5 times 0 is 0 plus 10. Y is going to be 10. So if no time has gone by, the tree is currently 10 inches. If 10 years have gone by, we're going to plug that in for x. 2/5 times 10 is going to give me 4 plus 10, or 14 inches. Let's plug 20 in for our equation. 2/5 times 20, that's 8 plus 10, or 18. Plug in 30. 2/5 times 30, that's 2 times 30 divided by 5. 12 plus 10, 22. And finally, let's plug in 40. 2/5 times 40 is 2 times 40, which is 80 divided by 5, which is 16, plus our 10 inches to start. So 26 inches is the diameter of the tree. Now we want to, step 2, draw a graph. Again, I'm making my intervals what I need them to be to fit my scenario. So time, every other line is going to be 10. 10, 15, 20, 25, 30. So every line is 5. Up here, every line is 2. So I'm graphing my points. 0, 10, 10, 14, 20, 18, 30, 22, and 40, 26. And then I'm going to connect the dots because that makes sense in this problem. Okay, I'm going to find the slope by doing rise over run. There's my my run of 20. I went from 0 to 20, and then I went up from that point till I hit the line, which was a rise of 8. So my slope is rise over run. So the 8's on top, that's my rise, and 20 is my run. If you go up, it's positive. If you go down, it's negative. If you go right, it's positive. If you go left, it's negative. So 8/20, reduce that down. That gives me 2/5, and that is my slope, which we already knew, right? Because it told us it grows 2/5 a year. So y equals 2/5 x plus 10, which is what we have. Notice where the 2/5 comes from. And the y-intercept is equal to 10. It's not equal to 0, 0, is it? No, because it starts out at 10 inches. So there's your y-intercept in your equation. Relationship is linear but not proportional. It does not go through 0, 0. The y-intercept is not 0. Make a table and graph the solutions of the equation y equals negative 2x plus 1. Make the table. Plug in your values. I'm going to plug negative 1 in for x. That's going to give me 2 plus 1 or 3 for y. I'm going to plug in 0 for x. 2 times 0 is 0 plus 1. That's going to give me 1 for y. I'm going to plug in 1. Negative 2 times 1 is negative 2 plus 1 is going to be negative 1 for y. I'm going to plug in 2 for x. Negative 2 times 2 is negative 4 plus 1 is going to give me negative 3. And finally, I'll plug in 3. You can pick your own values, by the way. 2 times 3 is negative 6 plus 1 is negative 5. Then I graph those. Notice how I can make a graph that is like this, because sometimes I have negative numbers, don't I? So then I would put my axes in the center. So let's plot those points. There's negative 1, 3, 0, 1, 1, negative 1, 2, negative 3, and 3, negative 5. Connect my dots. There is my linear graph. Then I'm going to find my slope, which I already know because it's in my equation, but I'm going to do my rise over run. So there's my run. This time I'm going to the left, so it's going to be negative. I went 4 units to the left, and then I'm going to rise from there till I hit the line. It's going to be a rise of positive 8. So my slope is rise over run, 8 over negative 4, which is the same as negative 2, which is what is our equation? Y equals negative 2x plus 1. There's our slope. There is our y-intercept, and there it is. It's our b. Relationship is linear but not proportional. It does not go through 0, 0. The y-intercept is not 0. Okay? Okay, it's your turn to try some of these. See you back. Welcome back. Let's focus on some higher order thinking. George observes that for every increase of 1 in the value of x, there is an increase of 60 in the corresponding value of y. He claims that the relationship represented by the table is proportional. Is George correct? Why or why not? There's our table. So for every increase of 1 in x, 1, 2, 3, 4, 5, y goes up by 60. 90, 150, 210, 270, 330. Okay? George's observation that for every increase of 1 unit of x, there is a 60 unit increase in y. However, George is wrong to say the relationship is proportional. The rate of change is constant, the slope, right? But the ratio of y to x is not constant. This line does not have a point 0, 0. So if I were to do y over x, I'd do 90 divided by 1, 150 divided by 2, 210 divided by 3, etc. Two parallel lines are graphed on a coordinate plane. How many of the lines could represent proportional relationships? Okay, let's take a look. Only one of the lines will go through the origin, right? Any other parallel lines cannot also pass through the origin, right? They can go up or down from the origin, but they cannot be on the origin. Only one line fits that description, and if they're parallel, then they have to be the same distance apart. So only one. Those are all parallel lines, but only one goes through 0, 0. Explain how you can know if a linear relationship is non-proportional from just looking at a table. We already know it's not proportional if it doesn't go through 0, 0. In a table, the ratio y over x will not be equal. Explain how you can know if a linear relationship is non-proportional from a graph. The graph will not go through 0, 0, the origin. And explain how you can know if a linear relationship is non-proportional from an equation that will have a b. b will not be equal to 0. So if it has a b, then it is not proportional. Okay, your homework is on Google Classroom. And I'll bring myself back here. And have a good day. I will see you soon. Bye.